this lesson is going to be a review of kinematics, some basic properties, and then we're going to go through some, just a practice question and then one problem set associated with kinematics. So we're going to start by reviewing some old notes that we took earlier in the year, as well as a problem we actually went through earlier in the year, and then we're going to go through a problem set with new problems and content in it. So a diagram that we've seen before, but I do want you guys to write it down in your notes for this review, is the staircase diagram here, where we have the top of the staircase. We're going to call that x of t, and x of t is going to represent the position. As a function of time. And then if we go down the staircase, that is going to be the velocity. And each time we go down a step, that's going to be taking the derivative. So this is velocity here. And then lastly is going to be the derivative of velocity. The first derivative of velocity, which is the second derivative of position, and that's the acceleration. Okay, so when you go down the staircase, you're taking the derivative. When you go up the staircase, you're taking the integral of each function to get to, let's say you're given acceleration and you want to find velocity, you take the integral of acceleration. Okay, next. The displacement of a function is equal to the integral of the velocity. The distance, not displacement, distance, is equal to the integral of the absolute value of velocity. Okay, and then diagram we've seen before is if I wanted to get from A to B, and I take some crazy route, that is the distance I've traveled here. However, the displacement is how far you are from the initial position when you stop. A pretty common question you're going to see is the position at points, let's call it t. T is going to be a common variable here. So if I want to find the position at a specific time, let's call it x of t, that is going to be equal to some initial position, x of a, plus the integral from a to t of the displacement. And we have to use a different variable here because we're already using t, so we're actually going to use we call this a dummy variable, and that variable in this case will be x. And so this is the position at point t equals a. Okay, so in other words, the way I want you guys to think about this is like, if I want to know the position of a car at some time, I take a known position of that car, and then I find the displacement from that known position. If I know a known position and I know the displacement from that known position, that will tell me where the car is located. And so that's the way I want you guys to think about how this formula is kind of set up. Okay, so let's go through a couple of examples. So practice. Let's say we have a car and it's traveling with a given velocity shown here. Let's talk about what it means for the car to be above and below the t-axis. So we're using t here instead of x. So if this car is above the t-axis, that means, so when v is above 0, or when v is positive, we're going to say the car is moving forward. when v is below 0, the car is moving backwards. Okay, so the y value of this graph will tell you whether or not the car is moving forward or moving backwards because it tells you the sign of the velocity. Okay, if I want to find the total distance that this car has traveled from our formula before, we're going from 0 to 0.7. We're dealing with a distance, so we want the absolute value of the velocity from 0 to 0.7. Okay, so in this case, we're going to find the total area under the curve, but because it's the absolute value, we're going to treat both regions here as a positive value. So even though this second one is below the x-axis, we're going to treat it as a positive. So let's find the area. Remember, the integral is the area under the curve, so we're going to find the area of this region here in red. Well, it's a trapezoid, so it's 1/2. The base, well, it's going to be 1/2 the height times the two bases, the way it's shaped. So the height is 60, and then the base is going to be 0.3 plus 0.1. And then we're going to add to it. So we're not subtracting, we're adding, because we're dealing with distance. We're going to add to it 1/2, the height is 20, the base is 0.3 plus 0.1. Okay, and so the result here is going to be, well, this is 1/2 times 60, which is 30, times 0.4, plus 10 times 0.4. So that's going to be 12 plus 4, so it's 16 kilometers. And that's the total distance that this individual, this car has traveled. And if I want the displacement, we're going to find the integral of just the velocity, not the absolute value of velocity, just the velocity itself. So it's going to be the same exact thing as before, except we're going to take this region in red, which we determined was 12 kilometers, and we're going to subtract the region in blue now. So we're not adding the region in blue, we're not subtracting the region in blue because the integrand is not the absolute value when we're dealing with the displacement. So we're going to subtract 4 kilometers. And that's going to be equal to 8 kilometers. Okay, so the total distance this car has traveled is 16 kilometers. The net displacement from the original position is 8 kilometers from 0 to 0.7 hours. Okay, to wrap up this video today, we're going to go through problem set number 1. So we have we're given these two statements. You can show these on the unit circle, but they give it to us, which is nice. And we know that the displacement of an object from a fixed point is given by the following function. So S of t is equal to t minus sine of 2 times t, where t is between 0 and pi. Okay, and so the first part of this question just wants us to evaluate the derivative of this. Okay, not too bad. We're just going to find the derivative of this. We don't have to plug anything in. So S prime of t is equal to the derivative of t, 1, minus the derivative of sine of 2t. Oh, because of the chain rule, the 2 will come out, and the derivative of sine is just cosine. So this is the value of the derivative. So that's the answer for 1a. Okay. There are two values of t for which the object is not moving. One value is pi over 6. Let's find the other value. So when the object is not moving, that means that the velocity of the function is going to be 0. Okay? So the velocity is 0. So what that means is the first derivative of the displacement is going to be 0. So let's set this answer from part A equal to 0. And if we solve for t, that's going to give us the time at which the particle is not moving. Okay. So to solve for t, let's isolate the trig term, cosine of 2t. So we get 2 cosine of 2t. We're going to add 1. We're going to add 2 cosine of 2t on both sides. So we're moving these two terms on the separate sides of the equation. Now let's divide by 2. Okay, so how to approach this? Well, cosine represents the x value on the unit circle. So cosine of 1/2, this is going to be the values on the unit circle that give you an x value of 1/2. So that's going to be up here and here. So pi over 3 is one of them. Pi over 3, that's 60 degrees. That's an x value 1/2 and a y value of root 3 over 2. And then the other one is over here, to round a little bit more. And so that is 5 pi over 3. That'll give you an x value of 1/2 and then a y value of negative root 3 over 2. So these are the two locations on the unit circle that give you an x value of 1/2. So what that means is, if I take the inverse cosine on both sides, 2t is equal to, there's actually two possible answers here, pi over 3 and 5 pi over 3. Okay, and then we're going to solve for t, we're going to divide by 2. Okay, so it tells us that one of the answers is pi over 6. What's the other value? That's going to be this one right here. So show that the values in between, or the value of the derivative is greater than 0 between these two values of t. So if we make a number line here, and this number line represents the sign of the first derivative, pi over 6, and then 5 pi over 6. The critical points are going to be the tick marks on the number line, and then the value of the first derivative will stay the same sign for each of these intervals, or these regions right here. So all we need to do is we need to pick a value between pi over 6 and 5 pi over 6, plug it into the derivative, and determine whether or not you get a positive value or a negative value. So let's pick pi over 2 and plug that into the first derivative. So 1 minus, a different color, 1 minus 2 cosine of 2 times pi over 2. Well, that's 1 minus 2 cosine of pi. So on the unit circle, cosine represents the x value at pi degrees on the unit circle, or pi radians on the unit circle. The x value is negative 1. And so cosine of pi is negative 1. And so we end up with 1 minus 2 times negative 1. And so this is 3, which means the value of the first derivative here between these 2 points is positive. And so we've proven that the value of the derivative is greater than 0 between these 2 points. Okay, let's wrap up this video by going through the last question, where we're going to identify the total distance traveled between these two values. So if we want the total distance traveled, we want the value of the absolute value. So this is letter D. So the distance is the integral from pi over 6 to 5 pi over 6 of the absolute value of the derivative of s. Okay, and what we're going to do here is we're going to evaluate what this is, and that will be the answer. So let's plug in the value of the derivative here. So this is 1 minus 2 cosine of 2t dt. Okay. The nice thing about this is that we know that the first derivative is positive for all values in between pi over 6 and 5 pi over 6. And what that means is the absolute value sign actually doesn't matter. It won't affect our answer. And that's going to make integrating this much easier. So we're going to integrate this normally. So to do that, we get, there's a few different ways you can approach this. You could do u substitution, but I think that's actually going to make it a little bit trickier if we do u sub. This becomes t minus, well, the integral of cosine is positive sine, so it's going to be, and then because of the chain rule, a 1/2 will come to the outside, and so we have, which will cancel out the 2, and so this becomes minus sine of 2t, evaluated from pi over 6 to 5 pi over 6. So now we're going to plug in pi over 6, subtract what we get when we plug in pi over 6, and then simplify that, and that will lead to our answer here. So 5 pi over 6 sine of 2 times 5 pi over 6, that's going to be 10 pi over 6, minus, let's write it like this, pi over 6 minus sine, well, if we multiply pi over 6 by 2, that is pi over 3. Okay, and now let's figure out what this expression is equal to. So 5 pi over 6, we'll just leave that alone. Let's think here. Well, 10 pi over 6 is going to be 2 pi over 6 less than 2 rotations around the unit circle. And so 10 pi over 6 is located down here. And the coordinate points here, if it's 2 pi over 6 less than 2 rotations, it's going to be 60 degrees as a reference angle, and so this is 1/2. This right here is 1/2, comma, negative root 3 over 2. Sine represents the y value, and so that will become, this becomes negative root 3 over 2. This is negative root 3 over 2. And then up here is going to be pi over 3. This is 1/2, comma, root 3 over 2. And this is pi over 3 here. And so the value here is square root of 3 over 2, positive. Okay. So we end up with, let's kind of rearrange the order here. Pi over 6. This is minus 3 pi over 2. Well, this negative gets distributed. So it becomes, so minus negative. So this becomes plus pi over 2 here, and this becomes plus pi over, root 3 over 2, sorry, over here as well. So we end up with root 3 over 2 for this term, positive, and then root 3 over 2 over here for this term, positive. Now let's just simplify this. We get 5 pi over 6 minus pi over 6, that's 4 pi over 6. Plus we have 2 root 3 over 2's, and so the final answer is going to be 2 pi over 3 plus the square root of 3. Okay, let's leave it like that. Okay, and to wrap up the lesson today, let me know if you have any questions on those problems we just went through, and then I want you guys to work through these 2 questions here on the OneNote.